Hello everyone. We have just a short video here where we're going to use Excel to double check our work that we did by hand, or once again see how that we calculate the range of optimality with the use of Excel. So I'm looking to back up the work that I did by hand with the fertilizer example, and again this is the exact same example that we have from our previous unit. If I had not already solved this model or set up this model in Excel, I would definitely have to do that first, because in order to use the aspect of Excel that will help us find the range of optimality, we will have to run Solver. Me having already done it and having set it all up, I will still have to run Solver again. So under my Data tab, clicking on Solver, making sure all my inputs are still accurate here. The objective function looks good. We are doing minimization. I have the correct cell references for my optimal solution, and all the constraints appear to be set up properly. So from here, I simply click Solve. And in doing so, the one thing I want to make sure that I do is after having Excel solve the problem, I want to make sure that I click on the sensitivity report. Immediately after hitting OK, what I should see is a new tab come up here. So right now I only have example 1, 2, 3, and 4. As soon as I hit OK, we now have a fifth tab, which is the sensitivity report. Looking at the information that in the sensitivity report, so we're looking up here where we are also given, once again, our optimal solution to use 15 pounds of fertilizer A and 2 pounds of fertilizer B. But what we can also take note of is the initial values for our two objective function coefficients, 0.97 for A and 1.89 for B, along with the maximum allowable decrease and increase. So to find the range of optimality, I would simply take my initial value for each of those. So for A, the initial value of 97 cents, and subtract the maximum allowable decrease to find the low end of the limit. And doing the exact same thing, but now taking that 97 cents and adding the maximum allowable increase, we should find that we get the exact same range of optimality that we did find graphically, and we are extremely confident that we have done all that sort of tricky stuff by hand correctly at this point. And similarly, because I've used cell references, I can simply copy and paste down, and I should quickly find that the range of optimality, my initial value of $1.89 minus the decrease to get the low end, and plus the increase to get the high end. And once again, we get the exact same values that we did by hand, or we find a range of optimality for fertilizer B being anywhere from a cost of $1.45.5 up to a maximum of $2.42.5 per pound. Please make sure that you are attempting this work on your own. Make sure you understand what you are doing with sensitivity analysis. In this case with optimality, what is changing, what isn't changing. All right? Remember, anytime we do sensitivity analysis, we can only change a single variable. If two variables change, then we have to reformulate the model. With optimality, or the range of optimality, if the only thing to change would be the price of fertilizer A, and that price changes only to within the range of optimality, what that is telling me is that this will not change. My optimal solution will not change. I will still use 15 pounds of A and 2 pounds of B, but what would change is the minimum cost. As soon as I change the cost of what one of those two fertilizers would cost me, then definitely my cost would change. But as long as it's only the one that changes, only A or only B, and it remains within the range of optimality, I would continue with my optimal solution of 15.2. Once it goes outside the range of optimality, the change in cost for either of those items, then once again, I would have to reformulate the model. Thank you all. Please email me any questions that you may have.